Here we learn two important concepts. One is specific heat. Yeah. So any substance temperature is increasing will require energy, right? Yeah. So this how much heat is required for the water temperature to reach 1 degree C. How much heat is required for lake temperature to rise 1 degree C? How much heat is required for a swimming pool temperature to reach 1 degree C? That's different. Even all other water. Specific heat. That means we want to know 1 gram water temperature. Temperature going up 1 degree C. How much energy is required? That is a specific heat. Specific heat is the amount of heat required to raise 1 degree C for the temperature of 1 gram of substance. Yeah, that's a specific heat. Yeah. Energy required for 1 gram substance, temperature going up 1 degree C. Yeah. How about the water? Water is very important. Yeah. So it will take 1 calorie to raise the temperature of 1 gram of water by 1 degree Celsius. So that is one specific heat for the water. Yeah. Yeah. So this is specific heat. 1 gram substance. Temperature going up 1 degree C. How much energy is required? So here just illustrate the specific heat for different substances. You see the water is maximum and S is 0.5. Yeah, you see the gold is minimum 0.031. Here is very, very important. You have to know the maximum specific heat. Yeah, water specific heat is highest. What does this mean? Could you tell me? That means 1 gram water temperature going up need a lot of energy. What does this mean? Take more heat, temperature raises a little. Yeah. And release more energy, temperature going down a little. That means water resists the temperature change. That's good. So for the Earth, 70% of Earth is covered by the water. So make this Earth temperature not a variation too much. It's stable. It's comfortable for human being. Yeah. So if this specific heat is lower. What does this mean? Like a silver. Take a little heat, temperature change a lot of, right? Yeah. So that's the temperature is different. You see, for our environmental, you see this temperature variation in New York, daytime and nighttime. The variation is larger in comparison with temperature variation in Las Vegas. Yeah, which one is the larger? Of course, Las Vegas. That's a desert. That's a specific heat is low. Daytime, nighttime. Daytime is very cold. Nighttime is very hot. Because the specific heat is low. Yeah. New York, San Francisco, temperature not change too much between daytime and nighttime. Specific heat. Yeah. So here is the question. Which city during summer will exhibit largest dino temperature variation? Yeah, Las Vegas. Yeah, Los Angeles. So here you see there is the water. Specific heat is the highest. So in the summer, you see where temperature is high, where temperature is low. Land, because the specific heat is low. Water is cool, specific heat is larger. Resist the temperature change. So land is hot, water is cool, heat is transfer from hot to the cool, energy loaded to the water. Then the water current is moving to the high latitude. And the high latitude where temperature high, where temperature low. Where the cold, where the warm. Land, because the specific heat is low. Land is cold. Water is warm. Energy is transfer from hot to cold, right? From here, uploaded energy to the water. Then the water moves to the high latitude. Then download to the land. You see energy transferred by the water from low latitude to the high latitude. Seventh is albedo, another parameter of the Earth. Yeah. What is albedo? Albedo is the fraction of solar energy reflected from Earth, yeah, back to space. Yeah. So this is the definition. Then incoming solar radiation. Yeah. So partially, a part is reflected. Yeah, cannot be totally absorbed. Yeah. Then reflected. Then some of them absorbed. Yeah. The reflected plus absorbed is equal incoming solar radiation. Why? Energy conservation law, right? Yeah. So here is albedo, how much reflected, yeah, how many, yeah, over incoming solar radiation. Snow, especially for the fresh snow, has a higher albedo. Yeah, this is 0.9. What does this mean? 90% of solar radiation is reflected. Yeah. And the snow is a poor absorber of solar radiation. Yeah, albedo is the highest. Yeah. Here, this table illustrates albedo for different land surface. Yeah. Fresh snow is the highest. Yeah. And like a sand and the different land cover for the grass and for the forest. Yeah. So that's the albedo, this percentage different. The Earth and the atmosphere, yeah, for the cloud is also there is a higher albedo. Yeah. What is the total average of Earth's albedo? Is 0.3, 30%. This is a very, very important parameter for the Earth. I think you have remember this. Yeah. That means incoming solar radiation to the Earth, 30% is reflected. Earth's average albedo is 0.3.